This is another example of the fundamental theorem of calculus 1. We want to find the derivative of this function. So we need g prime of x. Well, FTC 1 says that if you take the derivative of the integral of a function of t, if the integral is nice, if it's integrable, then the derivative is just a function f of x. Okay, so that's what it is. So we're going to see if we can differentiate this function. Well, this looks almost like that one, except that there I have x squared instead of x. Okay, so let's see if I can clean that. So I have f of x instead of, I have x squared instead of x. So how do I deal with this? So I'm going to let u be x squared. So this g of x becomes the integral from 0 to u of e to the power of sine of t dt, which I will call it as h of u. So g of x is really, maybe I'll call it little h of u, okay? So g of x is h of u of x. So this is u of x. So g of x is h of u of x. And the chain rule tells you that the derivative of g of x is the derivative of h of u of x times u prime of x. So we're going to take the derivative of h with respect to u and put u in, then take the derivative of u and multiply the result by that. But we can take the derivative of this one very easily. The derivative of this with respect to u of e to the power of sine of t dt is actually e to the power of sine of u. So g prime of x now becomes e to the power of sine of u of x times the derivative of u of x, which is equal to 2x. So this becomes 2x e to the power of sine of x squared. And that's the final answer. So to recap, I'm trying to use the fundamental theorem of calculus that tells me that you differentiate the integral from a to x of a function. You just put x into the place of t. Everywhere you see t, put x's. But now I don't have x here, I have x squared. To remedy, I will put u of x for x squared. So I put u of x. And then we try to differentiate with respect to u. With respect to x. So it's the chain rule that I'm going to have to use now. The derivative of g is derivative of h times u prime. H prime of u times u prime. But h prime of u is just put u in for t. That's what h prime of u is. That's nice. I can do that. And that's what I did here. I just put in u for t. In other words, I put in u for t. Okay, so I do that. Then multiply it by u prime of t. And that's what I did. So that's the derivative of g at x.